Hi, I'm Rich Cole. I'm here in our Naples, Florida shop at Cole Gunsmithing, and I'm going to show you how we do a mechanical trigger conversion on a Beretta DT11 trigger. So the first thing we're going to do is we're going to take it all apart. Here it is. So the reason that we do a mechanical trigger conversion is for people that want to shoot the small gauge 28 and certainly 410. One of the things about this conversion is it truly is mechanical. It's not a light inertia conversion, and therefore it is the actual mechanical motion which is happening that is what causes the gun to set up its second shot. So let's see if I can talk and work at the same time. So we've really got to pull this trigger assembly apart and get all the parts out of it, because part of what's going to end up happening here is we've got to soften the back end of the trigger plate so that we can machine it and drill it and tap it, because it's too hard right now in its state back here. It's too hard in order to be able to tap it, even if you could get a hole in it with a carbide drill. Okay, we're going to punch her. Okay, you can stop now. I'm going to take the mainsprings out here, and this is one where we say, watch your eyes. So you don't want that mainspring to come up and put an eye out. Come on. There we go. Okay, so now we've got a completely bare trigger assembly. So when I heat this, I don't have to worry about getting the flame on any parts that could be damaged by tempering. What I am going to do here is I'm going to give myself a little area that I can see up here where I'm working on. I'm going to take this plating off so that when we heat it, I can watch for the temper change. If I don't take that nickel off of that area, I won't be able to see when the temperature changes and goes from our straw to our purple down into our blue. And basically we're going to do this twice. We're not going to show you the whole thing. It just takes a little while, but we need to soften the back end of this in order to be able to machine it. So using my torch, I'm softening this post that houses the detent. And I'm going to watch for my color change, because when my color changes, I'm going to slowly back off, and then I'm just going to feather the torch a little bit to allow the part to cool slowly, because if it cools too fast, it becomes hard again. And we've just got to soften just the back end of this so that we can get a hole, a counter bore, and get it tapped. So here it comes. You can't see it, but now I see my color change. And so now I'm going to back my flame off slowly and just sort of feather this a little bit. And after I let it cool, I'm going to come back and I'm going to do it again, but at a slightly lower temperature. I'm not going to bring it up to as high a temperature. So this is the inertia block. We've got to modify the inertia block by welding a little tab out here on the end of it so that our cam screw will be able to activate this. And that's what the heart of the mechanical function is. So considering that we don't want to weld dirty parts, I'm going to take the oxide off of this right on the flat end. I'm just going to clean this with my file and my paper. I'm going to hit it with a little bit of solvent to make sure that there's no oil on it. And now we're going to go TIG weld this. Okay. So I'm all set up here. I'm going to TIG weld just a little ball of material to lengthen this hook out here. And I'm all set to go, but John is going to stop filming this because you can't see this because of the intensity of the light. So here's our little bit of weld. I don't know if you can sort of zoom in on that and see that it's just a tiny bit that we've added in order to create length there. And now we're going to file that and fit that surface.
Okay, sounds good. Thank you. Have a good day.
So basically, I'm reshaping this, and it's very, very important that they didn't make us a part that's easy to hang on to here. But it's very important that my surface here is perfectly level with the axis that the inertia block moves on. Because if it's not, it's going to cause us problems. I'm going to finish this on the grinder and the polisher. Okay, so now that we've shaped that and we've got the shape of our little mechanical foot correct, what we've got to do is we've got to reharden that, because if we leave this just a soft weld on a MIM-cast part like this, it's just going to wear and cause problems. So we're going to go this extra step. What I'm going to do is I'm going to heat this up. My little foot here, I'm going to heat this up, and into the case knit carburizing compound it goes. And then this is going to be pretty bright light. We're cooking this, and it is actually imparting carbon into the surface, the molecular structure of the surface of the steel that is being heated red hot, and then into the water for the quench.
This doesn't seem like a do-it-yourself thing for most people.
The people that do it themselves, I will gladly redo those jobs for them for just about twice the cost that we ordinarily would do it. The reason that we're doing this video is to just show people how the process is done. This is not a do-it-yourself job. You know, a person would have to have a fairly substantial level of skill and the correct tooling in order to do this. You'll see next when we go to machine the trigger plate, there's some specific fixturing that needs to be used in order to get the cam screw hole in the correct place, the correct location. And if that's not pretty much perfect, there's just no way to make the trigger system work properly. So here's our trigger plate. We've got this ready. It's on its fixture. So you can see the fixture that it's set up on. And this is what we're going to do, is we're going to machine this now. I've got it all set up and indicated, and it's on its stop. And basically we have 4 different operations that we're going to do on this. I'm going to flatten my top off here so that drill doesn't walk even with a thigh bushing. So that's a center cutting carbide end mill. And we're gonna, with a drill bushing, we're gonna drill our tap drill. Then we've got a carbide reamer to ream prior to tapping, and a clearance drill. But basically, this is what you're seeing. This is the machining part of this, and this is the reason that we had to anneal the back end of that trigger plate, because otherwise it would be too hard to be able to cut. Even annealed, this is pretty tough. We're going to use lots of cutting lubricant, and without this fixture, there would be absolutely no way to drill this, to have the hole come out at the right angle and the right position so that our cam screw would properly engage the cam tab that we've TIG welded and reshaped on the back of the inertia block. So we've machined the trigger plate, and we showed you a little piece of that, the first step of that, which was the drilling the hole for the tapped hole. There's also a counter bore that's cut into that hole, and then we run a carbide reamer through that to make sure the hole is perfectly straight, because drills can walk a little bit. And now here we're gonna tap this. Make sure that I set it up straight in the vise. I've actually already tapped this because the tapping is a very slow, tedious process of back and forth. Very easy to break a tap in hard material like this. But in any case, the tap has been run down through there. Okay, so the hole is tapped for our cam screw. Now, what we've got to do is we're gonna reassemble the trigger assembly now. Okay, so the first thing we're gonna do is we're gonna put in the little bridge that holds the mainsprings under tension just to set. So we're gonna put the mainsprings back in, and they're gonna pop back in under that bridge, just like so. Okay. So this is the trigger spring and the plunger, and we're putting that in place. And I've got this little tool that I use that has a little hole in the end of it to grab the end of that head on the plunger. And then there's a little hole in here so that I can trap that, because otherwise that would be very, very difficult to hold that spring and plunger in place. Okay. And now we're going to put the trigger in, with the trigger base with the inertia block. Here's the inertia block after it's been modified. The tab has been TIG welded on. Okay, no modification to the spring. Okay, trigger slides up through. The inertia block will fold down over. Now this is where the third hand would be good, but I happen to have conditioned fingers. If I can find my other pin in my basket here. There we go. And so we've got to line these up and then put that pivot pin through, just like so. And then that rolls back around through, and then I'll put my retaining pin in, and I can pull my little retainer out. Okay. So in a mechanical trigger conversion, it's very important that we not have any take-up between the inertia block primary hook and the tail of the first sear, because if we have any take-up between that one and then take-up between the secondary and the second sear, what happens is that the cam action will happen too soon. We don't want to have a whole lot of over travel in the trigger pull. So what we're going to do is we're going to take some of the take up out. This is a fixture that holds the sear, and what I'm doing is I'm applying a little bit of pressure and I'm bending the sear just a tiny bit down, And then what I'm going to do is I'm going to fit the tail end of the sear. And after we're all done, then we will heat treat just the tail end of the sear and make it a little bit harder than it comes from the factory, because we don't want any burnishing or wear there between the inertia block and the tail of the sear. So we've adjusted basically the set of the sear. I've heat treated the sear tail here and then polished this so that this is nice and smooth. Now we're going to put the sear spring in it, and this is the orientation that the sear spring goes. Okay. And then we'll reassemble the sears back into the trigger assembly. Just like that. Now we're going to cock the hammers, and then we're going to make sure that the inertia block goes back and forth freely. This is important in any DT, regardless whether it's mechanical or inertia. Okay, but this needs to be able to move back and forth freely. So I'm going to move it over my underbarrel first and hold it there with my thumb. I feel it. There's really no take up, but there's just a little bit of movement. Fire that barrel, let it come forward, check that. Okay, there we go. The secondary engagement for the second shot being the upper barrel. This one got a little bit of clearance there. Then we'll go back around the other direction. Upper barrel feels good. Lower barrel, probably going to take just a little bit more out of that one, but we're going to try it first. Now what I've done is I put my cam screw in. Here's my cam screw, okay? And what's happening here is this screw will tighten it down so that when we fire the first shot, okay, when we fire the first shot, the cam screw pulls the inertia block back on that little foot that we welded on there. There we go. It's picking up right there. So let's slow it down a little bit. Very slowly. Okay, my hammer released. Now my cam picks up. It's important that the cam not pick up too soon, or what you get is slipping. This is the problem with anybody that polishes the tails of the sears and the nose of the inertia block and then weakens the sear spring, is after those parts burnish themselves, you end up with a scenario where the sear will slip. I mean, where the inertia block slips off the tail of the sear before the hammer is released. So that's what I'm looking for very carefully here. I want to make sure that the hammer releases first, and now with the continued motion of the trigger, the inertia block disengages and has the correct clearance for the second shot. Okay. And we're going to come over to this side. We're picking up, then we disengage. That was a little bit too early, so we're going to back this off just a little bit. Right there. So that is the way a mechanical trigger conversion works. This is all ready to go back into the gun and go. So for those of you who want to do it at home, good luck to you.